My name's Jamie Sanson. As you've heard a couple of times already, I'm here to talk to you about Android app functions. So I've been working in Android for about a decade now. I started out in New Zealand and have actually moved to the UK relatively recently, sort of a year and a half ago. As Luke mentioned, I'm based in London. I work for Marks & Spencer in the mobile platform team, so I spend most of my time kind of in Gradle land or GitHub Action space. And I'm also a Google developer expert for Android, which is why I can be here today. So as I said, we're talking about this thing called app functions, which has come about in Android 16. Quick show of hands, has anyone actually heard about app functions? No one. Yeah, I'm not surprised. I put this talk together a month or so ago and kind of expected them to get a mention at I.O. Didn't happen. Yeah, I figured before we get in, I'm going to clarify something. There's no sort of inside information here. All of the content that's in this talk came about because of some sort of reverse engineering and speculation on my part, which is kind of cool because it means that some of the things we get to go through are sort of my methods of how you can sort of snoop on what Google's doing by looking through their open source code repos. But what this also means is this hasn't gone past Google. So none of this is an announcement, it's just kind of ramblings on my part. Onto the agenda. So we have kind of 5 sections. In between most of them, we'll pause for a couple of sort of quick questions, but then if you have any sort of longer form questions and you have the Slido link, then get into Slido, otherwise we'll do sort of bigger questions at the end. First, we're going to go through how I figured out app functions are a thing at all and how you could find all this information for yourself. We're then going to start live coding. So we're going to build an app function. We're going to try call an app function and see what happens. And finally, we'll talk a little bit about kind of what I think they're for and some predictions for the future. So as I said, we are going to be doing live coding. All of the code that we're going to be sort of showing on screen here already exists, so you can go to this repository. And there's a link to all the slides as well, so if anything's too far away from you, you can go in there and scroll along. I'll put the speaker notes up afterwards because they're a bit of a mess right now. You'll find 2 branches in this repository, so on main, that's all kind of the final code. So if you want to jump to the conclusions, it's all there. Otherwise, there's another branch presentation, which is where we're going to be starting from. Okay, everyone okay with that? We can move on? Cool. Okay, so app functions popped up, as I said, in Android 16. Specifically, they came into the API 36 editions, which were back in the developer previews. And this is really what there is. So there's not much to see. You can see there's really just 5 classes that were added to Android. There's a manager, because everything in Android has a manager. Then there's stuff that sort of looks like a web server. So there's a service, and then request and response modeling, and that's kind of it. So at first glance, just by sort of looking at what was in the package, my hunch was maybe this is a more specific version of an intent to maybe improve their behavior and make them a bit more transactional. For those who aren't familiar with intents, intents are kind of this core concept in Android that is a messaging object. So it's sort of used by the system to talk between different components. An example of that would be like starting an activity, which is a piece of UI. So if you click on an icon on your home screen, that fires an intent to the app to open, but also for background things like starting services or delivering broadcasts. And they are pretty crazy. I mean, they've been around for 20 years. They were sort of part of the original version of Android. And I mean, they've held up to everything that modern Android has needed. But they do have a couple of pitfalls. So the thing with intents is that when you build an app, you don't advertise what intents you do handle. You just filter out the ones you don't handle. And that makes it, as a developer of a different app, really tricky to discover what you can do on a device. And there's also no such thing as an intent schema. So if you fire an intent at an app and ask for a response, that response could just be anything. It's kind of just a binary object you can do whatever you want with. it might have the things you want in there, it might not. So based on the fact that app functions sort of have these request and response modelings, my hunch was that maybe we're trying to improve on intents. We're trying to create something that's a bit more transactional, that have definitions. So going a bit deeper, my next hunch was just, well, let's click into some of the classes and see what they say for themselves. And actually, there's quite a lot of useful stuff in here. So if we look at App Functions Manager, we get the first definition of what an app function actually is. So an app function is a piece of functionality that apps expose to the system for cross-app orchestration, which is kind of vague. You're sort of just exposing functionality and then people call it. So it kind of lines up with that better intents hypothesis, but that word orchestration is kind of an interesting choice because it then implies that it's not just calling one function. Maybe they exist to call multiple functions all at the same time. And actually, we just need to scroll down the page, and it gives us an example which confirms that. So I'll read this out because it might be kind of hard to read, but an assistant app is trying to fulfill the user request, save XYZ into my notes. That app then should list all the available functions from app search, and then it should identify an app that implements a function that creates a note, and then it should call the function to create a note. So definitely transactional, definitely more emphasis on discovery, but we're now talking about assistant apps. There's not much more we can learn from developer.android.com. There are some more specifics about sort of how you can construct the framework types, but one thing they do mention is that you shouldn't be using the framework types, you should be using an SDK. And by SDK, I figured it's probably AndroidX. So that's where I look next. Another little tidbit, if you aren't familiar with a tool called Android Code Search, this is a very useful link. So this is effectively a way for you to look into the Android-specific stuff in the Google monorepo. It's basically like a file browser, but it also is kind of a Git GUI, so you can see the changes that happen and browse around throughout the entire thing. So when you get there, you'll land on a page like this, which gives you a few different options to jump off. We'll go to AndroidX, and then within that, there's a platform framework support repository. Click on that, and you get here. And thankfully, App Functions is right at the top. I won't go too much more into any of this discovery process, because from here, it's just kind of clicking around and reading bits and pieces and trying to understand why it exists. But just from looking at this, we can probably infer a couple of things. So you can see that there's sort of 4 key packages over here. Well, 3, a stubby thing, and then some integration tests. And what that sort of implies in the AndroidX sense is that from the app functions directory, that maybe there's going to be some backwards compatibility. From the compiler side of things, that implies that there's going to be annotation processing involved, because that's kind of the naming scheme that Google tend to follow for their compiler plugins. And then there's a service, which is sort of like a runtime, separate runtime library for actually doing the app function things. One other useful thing that I found in here, before we go off my tangent of diving through code, is this sentence, 2 sentences, from the metadata package within the AndroidX app function stuff. And this reads, the app functions metadata package defines a set of classes that represent metadata for app functions, makes sense. And this metadata is designed to be similar in spirit to the OpenAPI specification, which is used to describe REST APIs. Which is pretty interesting, because what this is effectively saying is we want to build something that is transactional, is well-typed, and could be understood by other apps on the platform. There are some other highlights in that metadata document. I left a link to it in the slides if you want to look, but it says obviously there's no HTTP-related things because you're not talking between services. All the metadata for functions is stored in a system called App Search, which is sort of this like device-wide database that was added a few versions of Android ago. Can be queried really easily and propagates information across the device. All of the metadata for your functions originates in your APK, which is interesting. So that means that your functions kind of have to be built and defined at compile time. And there's also this notion of schemas. So we saw that in some previous wording. Create note schemas could potentially be ways of sharing these function definitions. So to kind of sum all that up, we know that apps can include functions. Functions have request and response modeling. Those requests and responses form some metadata that gets bundled into your APK. And there's going to be code gen that exists in the SDK that'll make writing functions easier. So we're going to try to jump into some code very shortly. And we'll run through what sort of writing one of these app functions looks like based on all that code we've found. But when I was actually writing this talk to start with, there wasn't actually a version of app functions that had been published, which means we needed to get our hands on a snapshot build. And that's where the second handy link comes in today, which is AndroidX.dev. AndroidX.dev is a kind of system that Google maintains for publishing snapshots of the AndroidX repository. So every time they commit to their main branch, this will kind of trigger a build, fire off some new artifacts, and then they're available to you just like any other library that you depend on in Android. The only thing you need to do is make sure you point your build to the right place. And when you go to that website, it'll give you all of this code, but I figured I'd chuck it in here to show how easy it is. Really, all you need to do is go to wherever you define your repositories, plug in AndroidX Dev snapshots link, and you'll see that there's a section for build number, which is, it changes for every commit. So every so often you just sort of update that and you can get new versions. And it's as easy as that. You may want to be more specific though. So this repository isn't the fastest out there. And if you put it in there, accidentally you might find that all of your AndroidX dependencies are coming from this snapshot thing, which is not only slow, but also means that Gradle can't do its magic caching of dependencies. So you can use something like this to say, I only want to include the AndroidX.app functions group, and everything else has to come from somewhere else. Or alternatively, if you don't want to mess around with that, as I said, there is actually alphas now, so I didn't need to put that section in at all, but that might have been interesting, hopefully. We're actually not going to use the alphas because in building out what we're going to be having a look at shortly, there were some issues with it, so we're still using the snapshots. And now we're going to get into writing an app function. A quick little overview of what we're going to look at here. So we sort of mentioned that there's a compiler artifact, so that does our code gen. That's one of the components we care about. There's this app function annotation that exists, and that sort of points that compiler thing in the right direction. There's a bound service. Don't worry too much about what that means, but it's effectively the thing under the hood that does the function stuff. And then there's various other bits and pieces that we don't need to worry about just yet. So we will switch to the IDE, but before we do that, I'll pause for a couple of seconds. Does anyone have any questions while we're here? Yes?
The app search database, does the user have to manually approve access?
That is a good question. No, I don't think so.
Could it not be like kind of cookies all over again, where you can see instantly all the apps that are installed?
I think it definitely could do, and I'm not 100% sure how the operating system governs that. There is a thing in Android called queries, which we'll see in a second, that you can sort of put in your manifest to say, this app can interact with these other apps, and you have to be very explicit with what application IDs you put in there. I don't know if there's an approval process in Google Play for putting that in.
Yeah,
but
assume it would need wider access than that if the assistant's only able to access the apps and things.
Exactly, and we will get to that. Yeah. So effectively, I think to use app search and talk to entries that other apps have put in there, you need queries to see everything else. Cool. Yep, one back here.
Yeah, it's just a question about when you're looking in code search, you said you show us
Yeah, that's a good question. In my experience, no, it's not very typical. Usually, I think a lot of the why comes out in more public forums. So it might be in the documentation on developer.android.com or talks that the Google developers do at bits and pieces. But yeah, it's the first kind of design document I've seen in AndroidX. There might be others, but like, yeah, it's kind of an interesting find. Cool. We will keep going just in the interest of time, but there'll be plenty of time to ask more questions afterwards. Okay, so in this project, this was the link that we had earlier, you'll see that there's two separate applications. So we have one application called Notos, so it's a note-taking app, and then one called Function Caller, which we'll look at in a bit. Our app is pretty basic, so it's a kind of like local-only note-taking app. Has a local database, and that's using something called SQLite, which I'm personally a huge fan of. Ever so quickly look at it, you can see we create a note table which has text, timestamp, and then there's a few queries. And the library that we're using then generates kind of all the code we need to interact with this thing, which is nice. Other than that, the app is very simple. Let's run it and see what it looks like. So this may be a touch too small, but as you can see, it's a note-taking app. There's no notes there, so we can add one. Hello Leeds mobile. Cool. So yeah, very basic. You can barely see that I typed that, but we continue. And within the app, it's again very basic. We've got two screens. A throwback to I/O, we're using Navigation 3, so we're using that instead of Nav 2, which has been fun so far. But that's really everything of note. Otherwise, it's just using everything else that's standard. So things like Hilt for dependency injection, and just first-party libraries for the most part. So we're going to start by creating a class where our app functions are going to live. I should have mentioned that I've already set up the library with kind of all the dependencies it needs, which you can see up here. So there's the app functions library itself, the service, and then the compiler. And these are all the ones that we saw just before. There's also a couple of things that I needed to plug into KSP to get it to work. And this I sort of found through trial and error by looking at the integration tests in AndroidX. I'm sure this will be documented at some point, or it's probably going to change, and none of this is going to be relevant, but these args exist so that we can actually do what we're doing. Anyway, let's go back to our class. We have that, I should have turned off AI code completion. Anyway, we have the app function annotation, so we can start with that. Suspend fun, create note. We'll give it a text, some string, and maybe we'll return a long, and that can be the ID. Let's start with that. So we have a function, suspending, which means we can do async stuff. We can give it a build, see what happens. And it gives us an error, which is nice. So it sort of guides you in the right direction. If we scroll over, it says the first parameter needs to be app function context. So if we put in a context, app function context, then import. And then if we build that, it all works. Cool. This app function context, if you're interested, it just gives you the regular context. I think I saw in a different version that it also had some information about the calling package and stuff like that, but I guess that's gone, so context. Okay, so that's built, which means we can see what KSP has done for us. So if we go into the generated build directory and go to KSP, you'll see that there are a few directories. We can ignore Java because that's Dagger stuff. There's some Kotlin, which is cool, so it's generating Kotlin, and then some resources. So let's start with the resources. We have two XML files. So there's app functions and app functions v2. So clearly behind the curve here if they're already on v2. v1 is very basic. You can see all it has in it is a function ID, which points to the thing that we've just built. So nota's app functions create note. And then v2 has a bit more information. So again, it's got the ID in there, and then some information about the parameters that it takes and a response. And this isn't super easy to parse, but from what I understand, these numbers sort of map to primitives. So 8 up here is a string, so that's the text we pass in, and 6 is a long, that's the thing we return. And then finally, there is a bunch of generated Kotlin, and there's a lot of it. You'll notice that almost everything is prepended with a $sign here, and I think that's so that they make it harder for people to accidentally reference these types because they don't really want you referencing these types. They're technically illegal identifiers in Java, but you can get to them in Kotlin if you try hard enough. And there's a bunch of stuff. The only thing that doesn't have a $sign in front of it is this thing which seems to aggregate all of the IDs of our functions. So what this implies, I think, is that you can create these functions and share this class around so that people can access a constant rather than hard coding a string, which could change. So that's nice. Otherwise, there's hooks to do kind of all the work. So there's an inventory, and this seems to just sort of map the function ID to an implementation of a thing. And then an invoker, which does the calling of the function from the looks of things. Yeah, you can see, there you go, create note. Aside from that, there's really just sort of more aggregation things. So you can see that's aggregated depths. If we had a project that had lots of modules, we could have app functions and other modules, presumably. So that's what that's for. And then some other generated stuff, which I guess wires that into app functions, puts it in that package, so maybe that makes it easier to access. Not sure. We'll leave the generated code where it is and go back to our app function because we haven't actually finished it yet, right? We have a function. I'll wrap these down so you can fit it all on one screen. We take the text, we return an ID, but we need a database. So we're using Hilt. We can just inject it. Private val database, and that could be our notes database. And then we can return database, notes queries, create. Text can be the text, and the timestamp can be now. Clock.system now. We'll just await for that to finish. And with that, I mean, that's our app function kind of implemented. The problem is app functions doesn't know how to create this type now. We say that Hilt and dependency injection creates this thing, but app functions doesn't have a Hilt tie-in, probably because it's so early days. It may have one eventually because we've seen like Hilt workers for Work Manager and whatnot, but currently you can't do that. So what we can do is go over to our application class and tell it how to create our thing. And that's not what I want. App function configuration. So all we need to do is implement this thing called app function configuration provider. This then gives us some configuration that we can plug into. So if we make that app function configuration.builder, build it, excuse the typing. You can see that we have a function on there we can called add and close in class factory. And the shape of that is you give it a class as a key and then a factory to create one. So if we just inject our enclosing class, our Notos app functions, we can then add and close in class factory for that class, and then just return it. And with that, it should all still build, and we've sort of wired up our app functions to work, theoretically. So that's really all there is to it, to implementing app functions. It is incredibly simple, really. I mean, this is just a function with an annotation on it. Presumably, this whole bit's going to go away at some point. So there's not a huge amount you need to do there. I think with that, we will switch back to... Let's pause for a second, just in case anyone had any questions about that code. Any questions about that?
I've got one. I've spoken with you before and I said like, a lot of my background's in iOS, so this might be a really stupid question because I guess my understanding of what's already available in Android might just be completely wrong. But I'm trying to figure out, in terms of what this actually enables the OS as well as other apps to do, right? So what we're saying here, what it's looking like to me, and I might be totally wrong and you might not even know, but a little bit like shortcuts on iOS where you can hold it in an app and it'll say, for example, on the Notes app, you'll get the create a note option.
Yeah.
We say this is just that, but with the option to pass in the parameter of here's the string that makes the note, and it's also accessible for another app.
So I think so, in a sense. I'll talk about it a bit later on near the end of the talk, but I think the iOS equivalent is kind of app intents,
Right.
which I think are from what I understand, the type that sort of underpins the shortcut stuff. So, but yeah, we'll talk about that in a sec. But
Okay.
yeah, definitely.
Sorry.
Cool. Any other questions, or should we keep diving back into some of the code? More code. Okay. So the next thing we're going to do is try and call that app function we have, and we have another app for that, which is convenient. The only type we need to interact with this time is this thing called App Functions Manager, which we saw right at the start. It was sort of that first framework class that was introduced. And there's really only three things you can do with this App Functions Manager. You can search for functions, which is pretty generic. You sort of pass in some search constraints and it'll give you a list of all the functions that might exist. You can invoke functions, conveniently, and you can enable and disable them. But critically, that last one, you can only do from your own app, so someone can't go along and turn your function off, which is nice. Back where we left off, so let's just install the app that we were just building, just to make sure it's all there. And okay, now we can switch over to our other app. This one is even more basic. So I'll run it so you can see what it does. It's effectively called it Ipsumify. The idea is it can just hopefully call our app function and create a note with lorem ipsum in it. So we jump into the source, and as I said, it's even more simple. I've wired it all up so we can sort of easily jump straight through it, but the UI, as you can see, has one note and one button. And when we click that button, we get a callback that goes all the way through to our activity. So just ignore the rest of the UI, and I won't show you because some of it's pretty janky. But the create note function is here, and that's what we can do stuff with. So we'll start by getting an instance of our manager. Let's go app functions manager. Oh, and this is worth shouting out. There's a compat version as well. So this is in the AndroidX app functions SDK. So that hunch originally about it maybe being backwards compatible was potentially true. So we can get instance from this. And if you actually look quickly into the source, you can see that there's sort of two branches of what happens within this function. So if you're on API 36 or above, you can then use the platform app function manager. But if you're on Tiramisu or above, so that's API 33, and an extension library is available, then you can also use something. The neat thing there is that presumably they can backport this functionality through, what do they call it? The sort of over-the-air updates that aren't full system updates, which is kind of cool. So hopefully this means the app functions won't be held back by people having to update their phones. Cool, so we have a manager. The return of this was nullable, but we don't care about that. So let's just return if it is. I'll wrap this down so you can see what's happening. These apps are also targeting SDK 36, so let's not worry about that either. All of the ways we can interact with this manager are suspending calls. So we're going to just get into a lifecycle scope is what I was looking for. We can get into a coroutine and then start playing around with it. So we'll start by trying to search for our function. Because as I said, there were sort of two things that you can do from other apps. So you can search for functions and you can call functions. And this is pretty easy to do. So manager.observe app functions. And then you can pass in a spec. So this is app functions search spec. This thing has a few things on it. We have, when we create this thing, we can pass in package names. So that's presumably of all the apps that we want to find app functions from. Schema categories and names. We haven't looked at schemas. I'm still not quite sure what the intention is, so we'll ignore those for now. And then schema versions as well. So that's kind of nifty. There's sort of version support in there too. But for now, let's just go package names, and we just want our app. So that's going to be dev, Sanson, Notos. Before we go any further, we mentioned queries before. Queries in Android are a way in which you can say, my app wants to talk to another app. So we should add a queries tag to our manifest. Package name is the same thing, dev, Sanson, Notos. And while we're here, there's one more thing we needed to add. We need the permission that allows us to execute app functions. So users permission execute app functions. There we go. Okay. So with that, we should be able to query our package and execute some functions. So we've asked to observe this, and this gives us a flow. So functions. We can then collect that flow. Functions collect. And then let's just print them out. Log.d, function caller. All right. Let's give this app a run. So what we should see is we click the button and we get some log output to say that we've found some functions. Okay, app is running. I might click the button and then switch to logcat if that's okay. So I click the button. We'll go over to logs. We can see app functions. There are some issues quite clearly. Runtime metadata not found for dev, Sanson, Notos, our function. So what we've seen is that the app has found the function, but there's clearly something kind of wrong. I'll be honest, not quite sure what this is. I think because so much of this is in flight, I think there's just stuff not implemented. So the search partially works because we can find the function that we care about, but we can't actually call it because whatever this runtime metadata is doesn't exist. So that's a bit of a shame. There's been mention of things like dynamic indexes, big words, don't know what they mean. So we will move on, and we know our function ID. So let's just try call it. Okay, so let's just get rid of all this. Manager execute app function. So this is again the other thing that you can call from a different app at this stage. So execute app function takes a request. Execute app function request, and this thing has a few different ways of interacting with it. But conveniently, we'll use this one. So target package name, which is going to be the other app we're trying to call. Function identifier, which we know as well. And then some parameters, which will be our text. So target package name is that one. Target function ID? Is that the right one? Yes, nice. And then parameters. Just double check the naming of this here. Function parameters. Function parameters is an app function parameter. App function data. Sorry, bear with me. App function data. I think we have called the right one. Just double check. Parameters, target package name, function identifier. Okay. So when we get to this stage, it's time to try and pass in parameters to our function. But unfortunately, creating one of these app function data things is a bit weird. They do have public constructors, but they're sort of odd to pass in. You can see that there's some bundle stuff going on, some document stuff, but they have this interesting thing, which we saw ever so briefly before, called app function serializable. And I think the idea behind this is that, as we saw where we generate some code, that code is a function ID that other apps can then depend on. We can do the same with our parameters. So we can wrap them into a type that can then be depended on through a library or something. And then apps can sort of interact directly with our function using a nice typed API. So we want app function serializable. This sort of looks and behaves a lot like Kotlin's serializable, except it does some pretty different things. And that's convenient. So it generated some code for us, but all we want is a data class with a named parameter. I'm not 100% sure if that name needs to match the one of our function. It would make sense if it does, but otherwise it's just a class that takes some text. And then we can pass that in through appfunctiondata.serialize. So that again takes a serializable and a class. So serializable is our app, we call it create note params, and text is the text, and finally serializable class is create note params class.java. Okay, it looks like we are missing a parameter. Help me out here if you've spotted anything. Got all the closing braces. We want this one. Target package name, function identifier, function parameters. Function identifier. There we go. Okay. So this should be enough for us to call our function. We've specified the package name, that's our app. We've told it the exact function we want to ask it about, and the parameters we want to pass to it. That'll then run, again it's suspending, it'll give us a result. So let's just, again, log that result and give it a run, see what happens. So again, I'll click the button and then we'll hop back over to logcat and see what happens. So, create note. Nothing's happened. Scroll down in logcat. Okay, so this is the line that we output. Create note result, app function response.error, error. Caller does not have permission to execute the app function. Okay, so we added the permission to the Android manifest. It's not a runtime permission, so we can't ask the system for it. But we could maybe just ask. So you can grant permissions in emulators and any kind of developer device through ADB. So let's just try that. Give it the permission it needs. ADB shell, PM, grant. Here's one I prepared earlier. The app ID and then the permission. So Android permission, execute app functions. Okay, so permission, Android permission, execute app functions, requested by the package, is not a changeable permission type. Does anyone know what that means? Okay, well that's convenient because I'm going to tell you what it means. So we wrote all this code. It looked great. We had the right permission in there. It got far enough for us to see the app function, but why can't we call it? So if you actually go to the documentation for this specific permission, that gives you a lot of information about what it is. You can see this allows an application to perform actions on behalf of users inside of applications. The next sentence says this permission is currently only granted to privileged system apps, and its protection level is internal and privileged. What that means is that the only way for your app to be granted this permission right now is for its application ID to be baked into Android. It has to be coded into the operating system and part of the AOSP distribution. It can't be something that you're granted right now. And while it was kind of fun putting together that demo app, I wasn't going to go as far as building Android, so sorry about that. I think from there, I mean, maybe it'll mean that this permission comes about in a later version of Android. I mean, this is all kind of very work in progress, or that's been my impression of it so far. So maybe this will go a bit broader, especially because it says currently. Pretty loaded term that. Let's hope to see it go a bit further. But not all hope is lost, because we can actually see it working. You can actually call your own app functions from your own app, which is presumably there for testing purposes. So we'll switch back to the code one more time, one very brief cut. We'll see it working, and then we'll sort of wrap up. Let's go over here and grab just all of this. I mean, we'll take that whole thing. And now if we close all of those, forget about function caller, let's go back to the Notos app. And if we go to the main activity, let's put this in there. Oh, we need the params class. Shouldn't have closed the activity. One moment. Grab this too. Put that up here somewhere. Okay. So we have the same function in here. We just need to call it. So we can just pipe that through to the floating action button that we had in this app in the bottom right corner. So if we go to our navigation, let's say on self create note, we'll make this a callback. Get rid of the generated code because we don't want that. And then we can go to our note screen. We're already piping through the action for add note and going to a different screen. So instead of doing that, let's call our function. So what was it? On self create note. And let's say hello from my own app function. I don't know. Oh, might help if we make that a string that we pass in there. Cool. So when we click that button, we'll call through this thing. If we go back to our navigation, we can then do exactly what that was telling us. So we can just pipe it through and call the function we want, create note. Okay, run the app again. Hopefully, we should see this working. So what we want to see when we click this button is that we get a new note. Fingers crossed. Hey, right, what's up? So you can play around with app functions. You can clearly write your own, and you can execute them, just not from other apps. I'll pause here because we're going to now go into sort of the speculation side of it, where I try and figure out what this is all for. Does anyone have any questions just on the code that we've seen? Cool. If not, feel free to hold them off until the end. Okay, so what are they all for? And I think that they're probably around for AI purposes. Specifically, something that's known as function calling. You may have heard of it as tool calling. It's tried to be formalized through this thing called MCP, which is the Model Context Protocol. And this diagram, which may be hopefully not too hard to see, tries to describe what this whole thing means. I stole this from like a Vertex AI talk. So anyway, you can think of it as having kind of three actors in the system. So you've got a user, which is you or me on your phone. There's the application, which might be the Gemini app or anything else. And then there's the model, which is the large language model running somewhere else. The way function calling or tool calling works is that when you as a user prompt through to the application to say, I want to do things, and that could be through text, or it could be however your app has sort of layered something in front of that prompt. Your application then also sends along function definitions. And these function definitions sort of give the model in its context all the stuff that it can do that isn't just responding to you with some really verbose sentences. So from there, when you then prompt the model to do things, which might be create a note that has lorem ipsum in it, it knows that there's a create note function. And from there, it can talk through to our application using sort of like special syntax, which is sort of how it works under the hood. It gives the application a function ID, the parameters it wants to pass in, and then under the hood, the application can interpret that as a function call. From there, it'll call out, do whatever it wants to do. So this calling to a service might be our app functions execution request thing. The result of that is then piped back to the large language model, and it decides what to do with it. It might call some more functions, it might just return back to the user, whatnot. So this is really how like a lot of the sort of agentic workflows you start seeing in developer land work. All the ones that sort of control your project, write code on your behalf. It's all sort of done, well, some of the more modern ones are now mostly done through this kind of tool calling approach. So app functions kind of fit into this function calling land pretty well. I mean, you can query function definitions from app search, and then if you have the right permission and you can sort of access enough apps on the device, then all of a sudden, all of the apps on your device become tools that some LLM can sort of talk to. And I think that makes a bit more sense if you think about the search or the observe app functions kind of signature of that function that we got, where you sort of pass in this relatively broad search query, and it gives you back some stuff that would be pretty tricky to write your own code against, right? Like if it gives you 10 functions and they all take random different parameters and give you random different responses, as a developer, you don't really want to write code directly against that, but it kind of makes sense if you are querying all the app functions and feeding that information through to an LLM as they change. So some conclusions from that is that they are kind of similar to iOS app intents. App intents in iOS are the sort of functionality behind shortcuts. So it's a thing that iOS apps can implement where you, again, define parameters and response sort of return types, but you also add a couple of other bits and pieces to it. So you give it a title, so there's some UI implication there, and that'll show up in the Shortcuts app, as well as some other stuff you can configure with it, like whether someone needs to be has to have their phone unlocked, for example. And app functions aren't really the same. Like they definitely do some of it. They do the function input and output, but they don't do the UI stuff. So they could be lower level. Maybe something in Android is going to come along and build on top of them, and we'll get to something similar. Maybe not. Only time will tell. So we'll round out with a couple of predictions. And this is definitely me just coming up with some stuff that this sort of feels right. App functions are probably for LLMs, but emphasis on the probably. Like we've seen schemas, which we didn't actually look at, but it's effectively, you can define type representations of these things. So I don't think they're always for LLMs. I think as developers, we will end up building against them at some point. You could imagine, pretty much every Android device is going to have a calendar app. There may be some sort of common calendar schema that means we can create events and whatnot. And if that is then something that's published and we all depend on, then we can create events through app functions, and that makes sense. But I think that discovery mechanism is pretty telling that there's sort of more than one purpose behind this. The other thing that is probably pretty obvious from this demo is that we're not going to see them in production for a while. On top of just sort of building this code and seeing that it doesn't work, I went through not all of them, some of Google's first-party apps and decompiled them to see if they have those assets in them, the app functions assets, and none of them do. So usually if Google were trying to run with a feature like this, they would make sure their apps support it out of the box, and they don't right now. But also the fact that it baked in App ID, so to get the permission to actually do anything. the only way to be granted that permission is through an OS update, which is pretty chunky and hefty on Google's end. So we might see them maybe within the next year, but probably Android 17. But if you think about how all of these things work and the LLM hypothesis, then this might be the start of Android becoming this kind of agentic operating system. I think reading between the lines of some of the code that exists, this could point to like a new way of talking to your device and having it do stuff for you. And that's kind of interesting, right? Like all of the use cases of maybe you're wearing the new glasses that showed up at I/O, and you want to get your app to perform some actions and some apps that you have without actually having to open the app. That could be useful. Hands-free in cars, that could be really useful too. And it's sort of, yeah, I don't know. This feels right. I think this is probably where it's going. But again, I think only time will tell. So, some conclusions. App functions are better intents. I think we've confirmed that. They are typed transactional things. They aren't necessarily doing everything that intents are doing because they're not opening apps, they're not starting services, kind of are. But they are very much input and output oriented, and that's kind of cool. You can build them, and you can play around with them. You can write some tests against them. And maybe you want to build your own agentic app that uses app functions from within your own app. I'm not sure why you do that, but you can build them. You just can't call them from other apps. And the use case is probably AI, but not necessarily. And with that, that's that. Does anyone have any questions? Yeah, sorry.
I have a couple of questions.
Yeah.
So first up, basically, have I understood it correctly that you're talking about two mobile apps, but they can't call each other. So you are not opening the app, but you're using the functions of that other app, right?
Yeah.
Yeah. So my follow-up question is basically, why are we doing this? Is it to make the app less bulkier so that the business logic of this mobile app stays with this one, and the other one has its own business logic, like whatever AI and LLM thinks, basically?
Yeah. Interesting question. I think partly yes. It feels like the intention behind this is to make it so that apps on the device can use more from other apps, which, if you take that to the extreme, means you might not need to build everything. You can just use something that someone else has implemented. So yeah, maybe. Yeah. Does that kind of answer the question?
Yeah, basically, I had a follow-up question very much related to this, which was, like we have seen here in the demo, as well as like how I could understand it, you really need to know both the apps, right? Like
Yeah.
to actually use it.
And
You know
yeah.
your mobile app as well as the other mobile app.
Exactly.
So as to make
And
it work.
I think that's probably where that schema stuff is going to come in, sort of as I've mentioned. Didn't show it, probably regretfully, but it feels like that's going to be the central point where, like the calendar example, there may be an agreed upon calendar function schema that Google Calendar implements or whatever other calendar implements, and then you can just interact with it that way. So that might be where it's going. Yeah, not sure. Cool. I had a question back here. Yes.
I would like to ask, for instance, I have an application which call this kind of app functions, but can I observe changes of list of these functions, like observer of Bluetooth devices or something else? If list of functions will be changed in future, can I observe it in runtime in application?
Yeah, so the observe app functions function that we demoed briefly returns a flow, and so that's that sort of
Like
reactive
coroutines.
thing. Coroutines flow, yeah. Although at the moment I don't think anything can add to the function list, like over time. I suppose new apps could be installed and that might add more functions, or other apps could enable and disable things. So yeah, there's a use case for it, I suppose. But yeah, it does exist, which is nice. Cool. Sorry, you have one down here. Yep.
I wonder if like the workflow will be kind of similar to the way Intents was implemented, like way back when, for instance, you have an app that says, play this song, and it could basically pop something up on the UI and say, these 6 apps on your device can handle this, and you can choose one and say, choose this one forever kind of thing, and then you get
Yeah.
an issue as well.
Because that is an interesting one, right? Like if you have multiple apps on your phone that can create notes, and you just tell some LLM to create a note, how does it know where to go? So yeah, maybe there is some notion of preferred app for certain things, or yeah. But yeah, again, I haven't really seen that in the operating system yet, so that might again point to it just not being ready yet. So, cool. Question back there. Yeah.
I'm just intrigued in the part of the process which happens between when you talk to, say, HTML, for example, and then it goes and finds the relevant app in a function. You mentioned was it app search, which has this index of these app functions.
Yeah.
Where does that kind of registration of app functions happen? Is that when you upload the app to Play Store and it automatically does it, or do you kind of manually manage yourself? Or
So it happens at install time. I can very briefly show the code because all we need to do is look at the merged manifest of one of these apps. So if we go to the one with the function in it, we go to the manifest and go merged. This might be a touch small. Can I move that over? So we can see there's obviously been a few things in here that have been added, but if we scroll down, we can start seeing some of the app function services. And you can see that there are two registered. So one's platform, one's extension. So this is presumably platform will be the one that is run on API 36 and above, extension 33 to 36. And they have properties that link to those generated resource files that we saw before, the assets. So my hunch, I haven't 100% confirmed it, but my hunch is when you install the app, Android will look at your manifest, do all its parsing, and do whatever it needs to do. It'll start these services, which will then read the functions and index them that way. So I think that's how it works. But yeah, again, kind of guessing.
So app search lives locally on the device. It's not a global list of app functions. It's like
Yeah, exactly. It lives on the device, and yeah, it's sort of added to by a bunch of different apps. Yeah. Cool. I had a question at the front here.
First off, does anybody remember that thing Google released? It's got to be about 7-8 years ago to build up chats for speakers, so Google Home and stuff like that. And you could create a set of functions, and then it'd work on Google Home, it'd work on a little chat UI, it'd work on Alexa and some other stuff as well.
Yeah.
It was very, very similar to that. It reminds me a lot of that.
So I think that was called App Actions. And it does feel a lot like this is a sort of an iteration of it, right? Like a, yeah.
Second, did you try? I'm guessing it's a yes, but did you try Assistant just to see if it worked, or Gemini just type in, add a note, and see if it picks it up?
I did not, but I should have. It would have been a good idea.
I'm really curious now.
We can try it afterwards. Cool. I've just noticed the time, so let's we'll pause questions now, and we can have a chat afterwards. Hang around. I'll be around for drinks afterwards, but don't want to hold up Harriet too much longer. So thank you very much for having me. I've been Jamie Sanson. You can find me on everything as @JamieSanson. Cheers.